Hello and welcome back to Mrs. Law's class. In this lesson, I'm going to show you how to factor expressions with common factors. Now, to start us off, let's take a look at the relationship between the distributive property and factoring. Recall from our previous section that when the greatest common factor is known, the sum of two or more numbers can be written as a product. So here is that same example. We have 24 plus 42 plus 60. So we know that 6 is the greatest common factor out of all these three numbers, and we can rewrite this as 6 times 4. 42 can be written as 6 times 7, and 60 can be rewritten as 6 times 10. Now, since all of these numbers are divisible by 6, we can rewrite this as 6, open up a bracket, and write this as 4 plus 7 plus 10. So this is the reverse of the distributive property. If I actually multiply 6 back in, 6 times 4 plus 6 times 7 plus 6 times 10, I actually get back this expression here that I started off with. So this process of writing a number or even a polynomial as a product is called factoring. And that is what happened when I took out the 6. I factored it out of these three numbers. 24 plus 42 plus 60. Now, we use the distributive property to change a product into a sum. So, for example, we have here 5 times 2x minus 3. So when I distribute, I'm going to go 5 times 2x, which is 10x, and then 5 times negative 3, which is negative 15. When we factor, we do the reverse process, and we change the sum into a product. So let's take our 10x minus 15, and we know that 5 is the greatest common factor of 10x and 15. So we're going to rewrite this with a 5 in the front, and we're going to go 10x divided by 5, which is 2x, and then negative 15 divided by 5 is negative 3. So you'll find that factoring might be a little bit more difficult because we have to divide. But after you've done the factoring, check it by multiplying the number back in. So if I go 5 times 2x, I get 10x, which is what we start with. And then 5 times negative 3 is negative 15. So I now know that I factored this correctly. Let's take a look at factoring expressions with common factors a little bit more closely. So to factor, find the greatest common factor of all the terms in the polynomial, then divide, notice it's division, divide each term in the polynomial by this greatest common factor. So let's start off with a couple of easier examples. Fill in the missing factor or term. So in this first example, we have 15x plus 18y. So we can see that we have a blank in front of this binomial. The binomial is 5x plus 6y. So we can see that the thing or the term that goes in this blank is the greatest common factor. So seeing that this is 5x, 15x divided by 5x gives me 3. 18y divided by 6y also gives me 3. So we know that this greatest common factor is 3. Now we can also check by multiplying this back in and distributing. So 3 times 5x is 15x. 3 times 6y is 18y. So that is good. That's correct. Let's take a look at the second one. So this time, the greatest common factor is already shown. It says that it is 5x. So what we're going to do to help you, we're going to divide each term by 5x. So 10x cubed divided by 5x is 2x squared. 5x squared divided by 5x is simply just x. And then 15x divided by 5x is 3. So 15 divided by 5 is 3, and the x's cancel off. And that's what goes in the blank. Let's now take a look at some examples where we have to find the greatest common factor and also the terms inside the brackets. So here we have this first one, 12x plus 28. So the greatest common factor of 12x and 28 is 4. So I'm going to rewrite this with a 4 in the front, and then we're going to open a bracket. So if you need to, write the divide by 4 underneath so you know what the terms will be inside. So 12x divided by 4 is 3x, and then 28 divided by 4 is plus 7. And again, we can check by multiplying this in. So 4 times 3x is 12x. 4 times 7 is 28. All right, the next one. So 7x squared minus 14x. Greatest common factor is going to be 7. And we also need an x because one has an x squared, one has an x. So 7x is my GCF. And again, if you need to write this down, write the 7x underneath to show yourself and to remind you what you are dividing. So 7x squared divided by 7x. The 7's cross off, but we'll have an x left over. And then we have minus 14 divided by 7, which is negative 2. And then the x's cross off. So there's no variable here. All right, let's take a look at another one. So progressively getting a little bit more difficult. So the GCF here is 4 and 6 we have is 2, x squared and x. We always take the smallest variable. Sorry, not the smallest variable, but the variable with the smallest exponent. So in this case, this would be x to the power of 1. And then we have a y squared and y squared. Now we don't have a z because the first term doesn't have any z's, although the second term does. So that is not common to both of them. All right, so here we will write this underneath again, 2xy squared and 2xy squared. So dividing here, we have 4 divided by 2 is 2. X squared divided by x is x to the power of 1, or just x. And then the y squared and the y squared crosses off. Okay, then we have a minus. 6 divided by 2 is 3. X divided by x crosses off. Y squared divided by y squared crosses off. So we just have the z squared left. All right, here we have 3 more examples. If you would like, pause the video now to try them on your own first, and then you can start and replay it again. The GCF here is 3, so I'm actually not going to show the division anymore. I'm just going to write the 3 in the front. 9x divided by 3 is 3x. Negative 6y divided by 3 is going to be negative 2, and then y. And then positive 12 divided by 3 is going to be plus 4. Okay, the next one, E, we have the GCF of 6 and also an x. So 6x cubed divided by 6x is x squared. Negative 24 x squared divided by 6x is negative 4. And we have an x. And then 12x divided by 6x is plus 2. All right, last one here. This is a big one. So 30, 15, and 25. GCF is 5. The variable with the smallest exponent is m squared and n. So we can take a mix match of different variables from different terms. So dividing, 30 divided by 5 is 6. M cubed divided by m squared is m. N's cancel off. Okay, negative 15 divided by 5, negative 3. M squareds cross off. N squared divided by n is n. And the last term, we have plus 25 divided by 5 is 5. M to the 4 divided by m squared is m squared. Remember, we are subtracting exponents. And then n cubed divided by n is n squared. All right, so that's how you factor by taking out a common factor. Now, I want to finish off by taking a look at a more complicated question here. So here I want to factor as well, but we don't have our typical common factor where it's just a single number or a number times by a variable or even just a variable itself. But what we have is a common factor that is actually a whole binomial. So similar to what we did before, we're going to factor out that common number. So here we factored out a 3 that was common to all of them. So here what we're doing is we're factoring out an x minus 2. So when we do that, we have x minus 2. Now, if I write down what we wrote before when we first started, let's say I'm going to divide by x minus 2 in the first term and divide by x minus 2 in the second term. So we can see that the x minus 2, they both cross off. And what we have left is our x and our plus 3. And that's what's going to go in the bracket, in the second bracket. So x plus 3. Let's try the second one. So both of them have a common factor that is a binomial of a minus b. So we write a minus b. So after we factor that out, because we are going to divide by a minus b for both terms, so they cross off, we have left 2a plus a squared. So you have 2a plus a squared. So this is how you factor a binomial common factor.